In the run-up to World Poetry Day this year, we ran a family-friendly webinar. What made this webinar unique, however, was the fact that we explained our science programme and the science projects that we host in the lab with poems. And this is a recording of that webinar. Enjoy.
And welcome to Dig Deep for Dazzling Verse with the Boulby Underground Laboratory. My name is Lauren and I will be your host on the surface today, telling you a little bit about what's going on. And then we will meet our team who are underground, who will be telling us some wonderful poetry and introducing our primary school poetry competition. Okay, so as I said, my name is Lauren. I am not underground today. I am based on the surface, but I am from the Science and Technology Facilities Council, which is a bit of a long name for something that's actually really, really cool. We're funded by UKRI and we run labs all around the country. So I am based here down in Oxfordshire, so some of you might be local to me, but if you're not, hello from far away, or if you are, hello from nearby. We are a lab down in Oxfordshire, but we don't just have the site that I work at, we have sites all over the UK. So we have a lab up in Daresbury called the Daresbury Laboratory in Cheshire. We have a site up in Edinburgh called the UK Astronomy Centre, UK Astronomy Technology Centre in Edinburgh. We have the Chilbolton Observatory down in Hampshire. We have a team that work at Polaris House in Swindon. And our most exciting lab that we're going to talk about today is the Boulby Underground Laboratory, which is based 1.1 kilometres underground in a working mine. Okay, so we're going to learn loads more about the lab today, but it is a working potash, polyhalite and salt mine in the northeast of England, and it is a special place for science. So here is the lab. I'm going to tell you a little bit about it before we journey underground, but you can see on the right, I'll get my little laser pointer out. This is what the mine looks like. If you live nearby, you might have seen it before. You might know some people that work there. But did you know underground that we actually have a lab? So our team go underground in something called the cage, which is a lift, and it only goes at certain times. So you have to make sure that you know what time it's going and you don't miss it, and that you remember you take your lunch underground. Otherwise, you might be a little bit hungry. So you can go underground in our lift, in our cage, and then you take a short walk and you end up at our lab. Now, you might be thinking, what do they wear to go underground? Well, you can see on the right here, this is a picture of some of the team. You might be able to spot me there in the middle. This is when people go underground, they wear the same clothes that the miners wear. So to get underground into the mine, you wear this orange PPE, so the personal protection equipment. And they have spats on their shins, so like shin guards, a hat, a helmet and a light. And they wear this great orange clothes. Now, when they get to the lab, it is really, really clean. And they do have to wear extra suits on top of their orange suits. Okay, so I filled you in a little bit about how we get to our mine and what goes on. But here today we are talking about poetry and poems. So my first question for you, and you can pop things in the Q&A if you've got any answers, or you can shout them out in your classroom, is just a question for you. What are poems? You might have heard about poetry before. Any ideas what poems are? And I will give you just a couple of seconds to shout out an answer. Nice. So I'm going to start to tell you that all poems are made up of words. And poems can tell a story or be about a thought or a feeling, and they can be serious or they can be silly, but they must always use words. So it's a piece of writing that uses some imaginative words to share the ideas, feelings or a story. And sometimes poems are short and rhythmic, so they have a rhythm, doop, 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 a bit like a song, but sometimes they're a bit longer and they're called longer narratives and have characters and plot lines a bit like a story. Okay. And my next question for you is, why do we read and write poems? Have a little think. Now, sometimes it can just be that poetry can simply put a smile on your face. It might make you laugh, which is a great reason to read it. But for some people, so for the people who are writing the poems, a poem is a really good way to express themselves. And often people choose to write about subjects that they're passionate about or that they've experienced. So if you went on a bus one day, you might write a poem about going on a bus, if you had a really nice time, or maybe if you didn't, something that they have done. And for somebody reading poems, it can be a way of connecting with a particular topic. So it might be that they really like going on buses and they want to read about poems on buses. So it can be a really good way of doing that. Now, for us working in science, it's really important to share stories and tell others about the work that we do, because you might not know that there's a lab in a mine and the cool stuff that we're doing. And it helps people to learn more about the world around them and to know that science is actually for everyone. And we try to reach people in ways that can inspire them or excite them. And one of the ways that we do this is through poetry. So hopefully we'll tell you some poems today, and then you'll think, actually, this science, I could be doing some of this science, or maybe you'll think that is just really cool and I'm really interested in that. So we're hoping to tell you some poems and you can learn a little bit about our science as well. Now, I've got one last question for you, is can you think of any types of poetry? Can you think of any types of poems? You might have done some at school, so you can have a little think. Any that you might have done. Give you a few moments just to have a little think. You can shout them out loud. And I'm going to tell you a few just in case. So you might have heard of a poem called a narrative poem. So narrative means story, and a narrative poem tells a story. And lots of poems are mainly about thoughts and feelings and not telling a story. So when it tells a story, that is a narrative poem. But there's also rhythm and rhyme. So you might have heard of poems that have bits that rhyme, the words that sound the same. And so it's a little bit more exciting than just a story because there's rhythm and rhyme. And some of the narratives poems also contain a bit of repetition. So you might go, oh, like this, and then like this, and then like this with the same rhymes. You might have heard that before. Now, I've had some people pop in the Q&A that they have heard of a limerick before. Well, lucky for you, I think we've got a few limericks for you to hear today. But they follow a strict rhyming pattern. So it goes the first and second line and the fifth line have the same rhyme and rhythm. And then the third and fourth line rhyme with each other as well. And we'll show you some of those as we go along. You might have heard of other poems like haikus or nonnets. That one might come up today. And maybe you've heard of an acrostic poem. So I'm going to share an acrostic poem with you today that is about Boulby. So with an acrostic poem, the first letter of the word of each line spells the word of the poem. So this is our poem called Boulby. Beneath the surface, deep underground, our teams of scientists, engineers and technicians undertake research to learn more about space, looking at leftover salt from an ancient sea. Brilliant people exploring our world. You could be part of it too. So that is our first acrostic poem of the day. Now, before we go underground, I think it's really, really important for you to see that journey of how our scientists and engineers and technicians have made it underground today to do the science and tell you all about the things that we're doing today. So I just wanted to remind you very, very quickly of our mine on the surface, and then they take the cage or the lift to go underground, and then they walk in the mine tunnels wearing their orange clothes to get to our underground lab. Okay. And then when they're in the lab, we're going to meet our team that are wearing our orange PPE. So I hope you're ready. I'm going to tell you a little poem as a voiceover to our video. So I'm going to change to our video now. There is no sound to this video, so don't worry. You don't need to hear anything. That's okay. And hopefully you're all sitting comfortably. Let's begin our journey underground. Here begins our journey. We'll walk together. Have no fear. We've got the map to Boulby Lab, but do shout if things aren't clear. We're currently on the surface, getting ready to go underground. Can you see those tall buildings? That's the mine in the background. Follow our team. We'll meet them later today. Downstairs into the lamp room. Orange suits lead the way. We pick up our tallies to keep track of who's in the mine. Put your ear defenders on. The cage must leave on time. Through an airlock we go to wait for our ride. Hand in our triangle tally. It's our turn inside. Everyone's in. Say goodbye to daylight. 7 minutes of darkness before pit bottom is in sight. The door will lift open and out we can leap. Take a look around now. We're 1.1 kilometers deep. The mine tunnels are huge, not tiny and small. Have you spotted the rocks that make up the wall? From the evaporation of the ancient Zechstein Sea, layers of salt are all that's left, the home for our laboratory. Away from pit bottom, it's quite dark down here, but switch on your head torch, there's nothing to fear. Endless tunnels may look like an underground maze, but soon you'll get familiar. The walk won't take days. This location is special, and here's my favourite verse, for our laboratory's a quiet place in the universe. Look down this salt tunnel, look out for a sign. Have we made it yet? Yes, it's our lab in a mine. What an amazing journey from up top to down there. There's so much going on here, we can't wait to share. It all happens in this lab, which itself is unique. It allows us to search for the knowledge that we seek. Let's go in and learn what there is to explore. A world of science is waiting behind this white door. Thank you. So I am going to hand over to Johnny now, who I believe is through that white door and in our lab. So Johnny, hello.
Hello, Lauren. Good afternoon, everybody. I hope you enjoyed that poem. I thought that was a really great poem. Thank you very much, Lauren, for sharing that. So that journey that you just saw, that journey underground that Lauren just described very beautifully in verse, that is the journey that I went on this morning. At about 9 o'clock this morning, I went down in the cage, went on that same trip underground that you just saw on the stream. And now I am 1.1 kilometers underground in Boulby Underground Laboratory. This is the main hall of our lab. This is where we host a lot of very important, very delicate particle physics experiments. So lots and lots of different science happens in the room behind me, as well as elsewhere in the lab. And what we're going to do now is we're going to show you around the science facility that we have down here. We're going to show you around the lab. We're going to tell you some poems, and we're going to talk a little bit about the science that we see down here in the mine. Now, Lauren, at the start of the link, told you about some different types of poems, some limericks, haikus, nonnets, acrostic poems. You even saw an acrostic poem just a few minutes ago. And all those different types of poems we will be encountering during our time underground today. Does that sound good with everybody? Okay, fantastic. So I'd like to get us started by telling you a limerick that I wrote yesterday. This is a limerick about the underground laboratory that you see behind me now. This is my limerick to welcome you to our lab. Now, a limerick, I'll remind you, is a form of poetry with a very specific rhyme scheme, where the first, second, and fifth lines all rhyme, and then the third and fourth lines rhyme with each other as well. And this is my limerick to welcome you to our lab. There once was a lab in a mine, whose science program was sublime. Muons from space were mostly erased, so dark matter detectors can thrive. But what is dark matter? And what is a dark matter detector? These are some of the types of science that we host underground in the space behind me. And I'm now going to hand you over to my colleague, Chris, who's going to tell you a little bit about dark matter and how we can look for it deep underground. Chris, are you there?
I think I'm here. Am I here? I think I
You
am.
are here. Hello, we can hear you.
Hello.
Take it away.
Thank you so much, Johnny, for a great introduction. Behind me is something very special, and I would like to tell you about it, but I'd not like to tell you about it in prose. I would like to tell you about it using a poem. Now, I'm going to use a normal narrative poem, quite long, so I hope you're all sitting very comfortably, and it's a pretty typical rhyming structure. Have a listen. What is it you think that you're made of? And what about animals or trees? Thinking bigger, what makes up mountains and what makes up our skies and our seas? Bigger still, what makes up a planet? What materials can build a star? The truth is that stars and planets are made of the very same stuff that you are. The whole universe is made up of particles which stick together in different ways. So everyone here is made of stardust. At least that's what our science says. Here's a question for you to ponder. Since we're all made of the same basic stuff, what's the heaviest stuff you can think of? It may seem easy, but it's actually quite tough. An elephant, a bus, every tree on the earth. Think bigger, like a planet or a star. A black hole, a galaxy? Nope, not even close. The darkness is heaviest by far. When you look to the moon and the stars in the night, it may seem there's not much to see. But in that deep darkness, in fact, all around us, are invisible particles. Trust me. But we know they are there thanks to science. We can detect the gravity they create. And that gravity keeps the galaxies together. And it's because these particles have weight. We call this heavy stuff dark matter because it can't make or reflect any light. But it's still very heavy and very important. Without it, our equations aren't right. The race is on to find dark matter. And what these detectors are for, we've been looking for years and not found it. But there's plenty of space to explore. So that's my poem about dark matter. And behind me is a dark matter detector, this weird, wonderful little sphere that I'm sort of holding in my hand. Is a really high-tech dark matter detector. It's a very clever piece of equipment that looks day and night for these invisible particles that we think exist. We think they're everywhere. They're millions upon millions of dark matter particles we think in our galaxy moving through our universe. And we're waiting very patiently, hoping that one of them will bump in to what's inside this very clever detector. And if it does, we'll be able to see that little bump and we'll be able to prove that dark matter exists. But it's a very, very hard job. We have to be very patient and we have to be in a quiet place in the universe, like Johnny and Laura told us about, in this wonderful lab deep underground where we're shielded from that background radiation. Only then, in the quiet silence of this low background environment, can we hear the faint whispers of what a dark matter particle might say inside our detector. So that's my dark matter detector. But there's plenty more that goes on down here. So I'm going to hand you back to Johnny, and he's going to tell you a bit more. You there, Johnny?
I am here, Chris. Hello. Thank you for that dark matter poem. I thought that was absolutely fantastic. What did everybody else think? Did we like it? I very much enjoyed it. So Chris was just talking about particles. And particles are like the fundamental building blocks of our universe. Particles are very, 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 very small, some of the smallest things that exist, and they're like building blocks that make up everything in the universe. Everything you can see around you is made of very, 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 very small particles. And particles are really, really interesting. Scientists like to study particles. We like to try and understand how they behave. And when particles interact with each other, they don't interact in the same way that things in everyday life do. The way that particles interact with each other is very, very strange. And we call this quantum physics. Quantum is a very fun word to say. Everybody try it. Quantum, quantum. It's a good word to say. It sounds a bit silly when you say it enough times. Quantum, quantum, quantum. Anyway, quantum physics. Very, very interesting thing. And it's all about how particles interact with each other because it's very strange the way that they do. And scientists want to study quantum physics and they want to understand how these particles interact. And this project behind me called Quasar, the Quantum Project, is all about that. Quasar is investigating how very, very, very cold particles interact with each other. And it does that by using lasers. Lasers are like very, very special beams of light. And I would now like to read you a limerick. Another limerick. I do quite like limericks, if you hadn't already guessed. A limerick about Quasar. And it goes like this. This project called Quasar has lasers, which cool atoms to super cold phases. In a cold quantum world, science laws will unfurl. The results will surely amaze us. That was my limerick about Quasar, the quantum mechanics experiment. So there's a lot of different science that you can do by being underground. You can try and look for mysterious, hard to detect dark matter particles, like Chris told you about, or you can study more familiar particles and how they behave in the realm of quantum physics. Okay, I'm going to hand you now back to Chris, who has moved a little bit down the lab and is now going to tell you about a different project. But I won't say any more than that. I'll let Chris explain. Chris is back. Hello.
Hello. I'm in a much noisier part of the lab now. And behind me is the experiment that I'd like to tell you about. But I'm not going to tell you its name. Instead, I'm going to use another acrostic poem, and you can find out the name as I read out my poem. Now, this acrostic poem hopefully will appear on the screen magically. There we are. And it should spell out the name of this experiment. So have a listen. Beneath the coast and seagull beaks, unknown locations this machine seeks. Truth behind the particle showers, technology testing across all hours, observing light with electronic eyes, nuclear reactors now supervised. So hopefully you can see that my acrostic poem has spelled out the word button. And that's what this is. This is the button detector. And the button detector is not, it's similar, but it's also different to some of the science. We're not exploring the mysteries of the universe. Instead, we're still trying to find particles, those little things that make up the universe, but we're trying to find particles that come from certain things. In this case, power plants, nuclear reactors. We can be able to see neutrinos coming from power plants, from those nuclear reactors, using this huge tank, this great big, it's basically a swimming bath. It's massive with electronic eyes inside. And they look for little flashes of light from these particles that come from power stations. So from being 1.1 kilometers underground, all that rock deep, we're able to see what's going on in the wider world using this very clever tank. I love science. But that's enough for me. I think I'm going to hand over now to someone that we've not met yet. We're going to go and meet Beth. Beth, are you there? There she is.
Hi,
Wonderful.
Chris. Thank you.
Over to you, Beth.
Hi, guys. I am wearing a little bit of a different outfit because I'm in a different room underground. This is our bugs clean room, and I'm going to start off by reading you a poem that I wrote about it. If I can get to the right page in my notebook. Do we really know the universe to its full extent? What if I told you what we see is only 15%? The rest of what's there cannot be seen, like the part of an iceberg that's under the sea. Dark matter is why scientists came underground, a particle that is still not yet found. They need an area of very low radiation for the dark matter detector creation. But isn't there radiation in every material in use? How do we get these contaminants to reduce? We need something so that we can be sure that we build these detectors to be ultra pure. But don't worry, we don't have to assume. The answer is here in this clean room. This is the Boulby Underground Screening Facility, measuring materials for their radioactivity, testing them for detector feasibility with our world-class detector sensitivity. This is where we house our bugs machines, deep underground where it's very clean. These look for gamma and alpha counts to find each radionuclide amount. Detectors worldwide require our support, awaiting their sample assay report. The detectors are kept cool by our LN65. They need to be at -175 for them to survive. With liquid nitrogen and high voltage applied, our germanium detectors are able to thrive, showing us results that would otherwise be unclear. It's fair to say I love working here. So that is my book's poem that I've written. I'm going to tell you a little bit about it. So the reason that I'm wearing a different outfit to Johnny and Chris in here is because it's even more clean in here. So we have to make sure that we have extra things like gloves and different shoes on so that we're not getting any dirt anywhere. This is because the samples and the detectors that are stored in here cannot have any contamination. So we have extra ventilation, which pushes all the dust out. And I have extra cleaning procedures, so we make sure it's clean all the time. And these detectors is where we put our sample materials. And from there, we can see exactly what's inside the materials, what type of radiation's in there. And this is really important for scientists when they're about to build their dark matter detectors, because they need to know exactly what's in there. So this is the first step to many projects around the world when they're building their detectors. And you can see the house in these lead castles. That's extra shielding to make sure it's ultra clean in there. And they have to be really, really cold, which is why we have these dewars here, making sure that they constantly have liquid nitrogen pumping through them. So we also have our XIA detectors that look for a little bit of a different type of radiation. And altogether, these different methods can make scientists really sure when they're building their detectors. So this is the first step in so many projects, and we get samples sent to us from all around the world, get to meet lots of different scientists from different underground labs who are building their own dark matter detectors too. So this is a really exciting place to work, knowing that each material I'm holding could one day find dark matter. It's really exciting to be a part of that. And before I finish up and send you back to Johnny, I am going to read you a poem that he wrote about books as well. This is a nonnet poem, so I hope I read it right. An ultra-sensitive detector needs ultra-clean materials with no contamination. So we select the best radio-quiet materials and check them in books pass. Thank you for listening to my talk about books. I'll pass you back to Johnny now, I think. You hopefully should be ready.
Hello. Thank you very much, Beth. I very much enjoyed those poems. When you saw me last inside, my clothes were less peculiar, but now I'm in the mine itself, and it's certainly less cool here. 30 degrees Celsius. It's like a summer's day. So it's a good job I've got my shorts on then and a light to guide my way. My helmet keeps my head safe if salt falls from the roof, and I've got shin guards on my legs to stop me from getting bruised. So welcome to our Mars yard, which is where we now will be, while I tell you about space exploration and renewable energy. That was my poem about the Mars yard, which is this part of the laboratory. This is the space that we have in the mine tunnels themselves, where we can do lots of different science beyond looking at particles. So we can do lots and lots and lots of different science by being underground. One thing that we can do is test robots. And I think this was the subject of Lauren's acrostic poem at the start of the webinar. Being underground, where I am now, is very, very different to where you are on the surface, or at least I hope it is, because where I currently am, it's really quite warm. It's about 30 degrees Celsius. It's like the warmest summer day that you can remember, but all of the time. It's also really dusty here. The rock that surrounds me is salt, the same sort of salt that you might put on your fish and chips. And that creates a lot of dust. So sometimes when a vehicle drives past me in the mine, it will kick some dust up from the floor, some salt dust, and you can taste it on your lips. It does taste almost salty. And the rocks that surround me here are 250 million years old. And being underground is what we might call an extreme environment. So an environment that's a little bit harsher than the surface and can be quite demanding, which makes it a really good place for testing robots, particularly Mars rovers. So before a team of scientists want to send a Mars rover to outer space, you can bring them down Boulby Mine to this space behind me, and you can put them through their paces. You can drive them up and down, you can get cameras to take photos, and you can test and make sure that the robots work in the way that you expect them to before you strap them to a rocket and send them to outer space. So you can test tires and wheels to see if the robots can handle this rough, gravelly, uneven terrain. You can test cameras to see how they fare in the low light conditions. This part of the mine is quite well lit, but other bits are a lot darker. And you can generally test how robust and how sturdy your robots are before you send them out into the world or onto another planet even. Now I'd like to read you a new type of poem that we've not seen yet this live link, but Lauren did mention it at the start. This is my personal favourite type of poem. It's called a haiku. And a haiku is a traditional form of Japanese poetry, and they're quite short. They're only made up of 3 lines. And haikus have a very specific structure, and it's all to do with syllables. The first line of a haiku must contain 5 syllables. The second line of a haiku must contain 7 syllables. And the final third line of a haiku must contain another 5 syllables. So 3 lines, 5 syllables, 7 syllables, 5 syllables. And I've got a haiku that I would now like to read you about exploring space and testing robots underground. The final frontier. A daunting land, prep required. Hence, robot playground. So they're quite short poems, but there are 5 syllables in the first line, 7 in the second, and 5 in the last one. Now, I'm going to take you on a bit of a journey now, quite literally. I'm going to pick up my laptop and we're going to walk down to the other end of the Mars yard, where I've got a few more things I'd like to show you. In fact, on the way, let me show you some pictures on the wall of some Mars rovers that we have tested underground here. This is a rover called Corey. Over here, we have a microscope, so a device for looking at very, very small things brought to us by NASA. And over here, we even have a picture from the time that a robot dog came underground from Manchester University. They were testing this robot dog underground to see how it fared in the mine environment. The next thing that I'd like to talk about is this project behind me. You see those space-age looking domes just over my shoulder? I won't walk down closer to them because my Wi-Fi tends to cut out about there. So I'll stay a little bit away so I remain connected. But that is a project called Biosphere. And Biosphere is a project that we host in conjunction with the University of Birmingham. And it's all about thinking about how would we set up habitation on Mars? If we want to explore Mars, if we want to send humans to Mars, how will we set up a base camp there? What will habitation look like? And what would our medical infrastructure look like? If someone gets poorly on Mars, what equipment will we need to take with us in order to treat them? And Mars is not a very nice place to be. It's very, very cold and there's not much oxygen there. And gravity is very different to what it is here on Earth. So if we do go to Mars, we'll need to make sure that we're very, very well prepared before setting up a home there. I'd like to read you another haiku. Like I said, they're my favorite type of poem, about setting up a base camp on Mars. And it goes a bit like this. Remember, 5 syllables, 7 syllables, 5 syllables. Red world, unlike Earth, of mountains tall and oceans dry. Strange choice for new home. That was my haiku about traveling to Mars. I'm going to walk over here just to the next project. And while I do, Does anyone think they'd want to travel to Mars one day? I think I'd want to go to Mars. Seems very challenging, but seems very exciting. So now, the last project that I want to talk to you about is this one behind me. It's a little hard to make out what you're looking at, but this is a project called Resource, and it's all about renewable energy. So energy that comes from natural sources that's good for the planet. Before I explain it, though, I would like to read you a poem about it. And it goes like this. The wind, the sun, the earth itself, the power of the sea. All of these great natural forces can give us energy. We call this type of power renewable energy, and engineers can use it to create electricity. Wind turbines and solar panels are great for planet Earth. They power our homes without releasing carbon dioxide first. But renewables are not perfect. New solutions must be found. And Resource is trying to store this energy in caverns underground. That was my poem about Resource. So yes, Resource is a project that we host where teams of researchers are trying to understand, can we store energy in the form of air in caverns underground? Renewable energy sources like wind turbines and solar panels are great for the planet because they give us electricity, they generate energy for us without releasing carbon dioxide into the atmosphere. But in order to make the most of our renewable energy resources, we need to find ways of storing the energy that they generate. And batteries, like normal batteries that you'd put in your TV remote, simply won't work for the amount of energy that we need to store. So scientists here at Boulby are trying to investigate ways of storing energy in the form of air in underground caverns. So around this space behind me, there are some holes in the floor. They're a bit hard to see. I'll see if there's one close enough. You can sort of see there's a little blue lid there. Beneath that is a hole in the floor, which leads down to a salt cavern. And you can use air stored and trapped in caverns as a form of storing energy. Think of it like blowing up a balloon. If you blow up a balloon, you store energy in the air in the balloon. And then when you release the balloon, you get the energy back out. And that's essentially what we're trying to do, but using caverns in salt. Okay, fantastic. I'm now going to read you one last poem before we hand back and go back to the main webinar. So let me find it quickly. So there we have it. That's the lab. I hope you enjoyed the tour. But just before we round this off, we have time for one thing more. We'd like to set a challenge for everyone on this link to write a poem of your own. So have a good old think. Haikus, limericks, nonnets, sonnets, rhyming or not. Any poem that you wish to write, we'd love to hear the lot. I'll hand you back to Lauren now to explain again in prose the challenge that we set to you and how to get involved. Lauren, are you there?
I am indeed, Johnny. Thank you so, so much. It has been absolutely amazing to visit you all underground and see all of the science that goes on there and hear some incredible poems. It has been absolutely fantastic. I have had a really amazing time. So I hope that you on this webinar have done as well. And luckily, we have recorded this. So hopefully you'll be able to watch it again if you would like to. But what I'm going to do now is just share a little bit about our competition, and then there will be time for some Q&A. So if you do have any questions that you'd like answered, you can pop them in, ask your teachers in just a few moments, but I will let you know, as Johnny said, in prose, so using my words, not in the form of a poem, to tell you about our poetry competition. Now, essentially, what we'd like you to do is write a poem about the Boulby Underground Laboratory or some of the science that we do. So you can have a go at doing a poem similar to what we shared with you today. So maybe you want to do an acrostic poem. Maybe you're like Johnny and really into haikus and you want to do a little haiku for us. You might want to have a go at doing a limerick. They were very good fun. We had a couple of those. Or a nonnet. So a nonnet was the one where it looks really cool when it's written down because there are, excuse me, 9 lines. Sorry about that. There are 9 lines. And the first line has 9 syllables. The second one has 8 syllables. The third line has 7 syllables, and then it goes 6, 5, 4, 3, 2, 1. And so with our bugs poem that Beth told us, it explained a little bit about what happened at bugs in that poem. And then the final line, the final syllable was pass, because our sample that we had been testing had passed, which I thought was really, really cool. So maybe you've been inspired by something that we do and you want to write a poem like that. Maybe you want to write a narrative poem, a little bit like a few of those that we've heard that tell a bit of a story, but with rhyme and rhythm. But maybe something has really, really inspired you. And some of you may have come along to our storytelling session last week. And if you didn't, don't worry, because that's recorded as well. And you can have a little listen to our storytelling session that was called The Little Robot and the Mars Mystery. And maybe you want to have a go at writing a poem about the further adventures of the little robot. Maybe you want to write an acrostic poem, so the one where all the letters of the first letter of each sentence make up the word of the thing that you're talking about in the poem. So our first one I introduced you to was called Boulby, and then Chris gave us an incredible poem called Button, about the button experiment. So maybe you want to have a go at doing one of those kinds of poems. And what we'd like you to do is write those poems. You can do it on a piece of paper or on the computer. And we would like you to get your teachers or your grown-ups at home to send it in to us online. We'd like you to do this by the 13th of March. I don't need to cough again. Send it to us by the 13th of So by midnight on the 12th of March, if you could send it to us online on this link, we will send this out into an email to everybody that's registered. So your teachers will definitely have this if you're watching this at school. So they will be able to send it to us. And what we will do is we will take a selection of those poems and we will read them out and do a recording of them underground. So our scientists and our engineers and our technicians, our team at the Boulby Underground Lab will read and record those poems, and we will release them on our social media pages as videos on World Poetry Day. So on the 21st of March is World Poetry Day. Now, we'll let you know in that week if we will contact your teachers or your grown-ups at home to tell you during that week whether or not we will be reading out your poem. So if your poem is going to be read underground, we will. And we'll just say your first name and then the initial of your surname when we're reading those out. So please do have a go at writing us a poem. You can add some beautiful pictures if you want to around if you do it by hand, but you don't have to, but just some of the things that we have been involved in. So maybe you're really interested in space or dark matter or robots in space or Mars or exploring different planets, or you're really interested in the mine. Please do have a go at that. So hopefully that tells you a little bit about our competition. And now we have got time for some questions. So I'm going to stop my share and hopefully my team at the Boulby Underground Lab are going to return. Amazing. I can see Johnny and Chris. Fantastic. And we are going to, if you've got, and Beth, amazing. Hello, Beth. we will ask any questions that you might have. So my first question that we've had in is to ask a little bit about what you do about food and drink when you're underground in the lab. Have you got a restaurant down there?
We do not have a restaurant underground, unfortunately, no. So we take our food down with us. So we catch the 9 a.m. lift ride down. So early morning, we'll pack our lunch, we'll pack some snacks for the day, and we'll take it all down with us in our backpacks. So if we're staying down quite late, like Beth, Chris, and I are, then we have our lunch with us that we can eat underground. We may be in a mine, but we do still have a microwave and we have a kettle so we can have tea and coffee as well. So we eat our lunch while we're down here. And we're big fans of biscuits as well. We eat a lot of biscuits.
Very, very important. Some people want to know, how long does it take to get underground?
That's a good question. So the lift itself takes about 7 minutes for us to get underground. And then depending on how fast we're walking, from the bottom of the lift to our lab, it's about a 10 to 15 minute walk. So altogether, including getting changed and stuff, it can take at least half an hour for us to get underground.
Amazing. And somebody has asked, and this is my favorite question as well. So Westgarth, this is the question I like to ask as well. So you say you're underground all day. Have you got toilets underground?
Well, we do have lots of tunnels. No, I'm kidding. Don't worry. We have a wonderful, wonderful toilet, which is in fact the deepest flushing toilet in Britain. We also have the second deepest flushing toilet in Britain, which is quite close to the first one. So we have both first and second steps on the podium covered.
Amazing. And our next question is, how do you have internet in the mine?
That's also a really, really good question. So like how at home or at school you have Wi-Fi routers or like a Wi-Fi box on the wall that allows you to connect wirelessly to the internet. We have the same thing in the laboratory that we're all in now. But then to get the internet connection from the mine up to the surface, we have a really, really, really long cable, a kilometer-long cable that goes from the underground lab all the way up to the surface. And it goes up the side of the lift shaft that we travel down in. So that video that you watched at the start of us going underground, down the side of that lift shaft is a really, 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 really long cable which carries all of our network.
So we've also been asked, what is your favorite part of being underground?
I think we'll all have different questions to this. I like being underground because I'm only focused on my work, and also because we always have such amazing visitors, because underground science is such a specific community and everyone's searching for the same things. So when you come, it's always really exciting to meet lots of new people and learn about the science that they're doing.
That's a great answer, Beth. I think that's a really good answer. For me personally, I like to tinker with things. I love bits of equipment. I love fixing things and pipe work and all sorts. You can see behind me, there's lots of things going on with these detectors. And part of the really exciting challenge for me is if something like this behind me goes wrong or it needs fixing, you can't pop to your local hardware shop and buy that bolt or nut. You've got to figure it out down here. You've got to problem solve. And it's a really fun challenge to try and solve these problems in this difficult environment. So I like the challenge.
That's also a really good answer. I really like that answer too, Chris, and yours, Beth. And I think my answer to the question is probably quite similar to Beth's, in that what I like most about working underground is how many different things you can get up to in just one day. So, for example, some days we might have people underground testing robots, or we might have people investigating how we might 3D print an ear on Mars. That's one of the things we've done as part of the Biosphere project before. So some days you'll be doing something like that, but then other days people might be installing dark matter detectors, or might be installing electronic eyes into our detectors. And then other days we might be having some big facility infrastructure work going on. So not to do with science altogether. Sometimes we'll be doing a lot of maintenance and operational work in the lab, and it's always so different and it's always so exciting. And that's what I like about it.
Amazing. Thank you. They are all incredible answers. This one, I'm hoping Chris will be able to maybe give us a visual on this, but somebody wants to know, how big is the lab?
Oh, I can certainly do that. If you bear with me. So, picture is worth 1,000 words. I'm standing in the main hall, which is a really long corridor. Lots of science, lots of experiments. My camera's trying to follow me, which is not helpful. You can see there's lots of experiments in this main hall. But then if I do a quick jog, run, then I get into the big main lek, the large experimental cavern, which is huge. It's got this enormous tank behind me, which is massive. And that's just the inside parts. Beth's in an entirely different section. And then Johnny's in the Mars yard, which goes even further. So it's really big, really, really big.
Brilliant.
Chris and Beth are through that door.
Yes, that is that white door that I mentioned at the start in my Journey Underground poem. Brilliant. And one group has asked, how long are the mine tunnels if they're all put together? You might not know the answer, but you might be able to explain how big the mine is.
That's a really good question. I think this is correct that if you lined them all up, you could get to, is it Sicily? You could get across Europe somewhere. It's the largest mine in the UK. And I think there's over 10,000 kilometers of mine tunnels. I think that's the answer. So it's very big.
I think it's something like you could line up 120 Eiffel Towers, something like that. Maybe more, maybe even more. Lots of Eiffel Towers, more Eiffel Towers that would be practical.
And how many Eiffel Towers deep are we?
Oh, we are 3 and a little bit extra Eiffel Towers, all stacked on top of each other. So if anyone's been to France, Paris, seen how tall the Eiffel Tower is, think of that Eiffel Tower, then another one on top of it, then another one on top of that, and then an extra bit for good measure. That's how deep we are. Lots of steps.
And in that sort of same sort of thing. So if you are so far underground, how does the roof stay up? How are you not just underground even more and not in a tunnel?
That is a very, very good question. Yes. So the rock that surrounds us is salt. So the floor behind me is made of salt. The roof is made of salt. The walls are made of salt. And this rock salt is the same sort of salt that you might put on your fish and chips. If you give me 5 seconds, I'm going to run over to a table and grab you a really nice piece of salt to show you. 1 sec.
Okie dokie, Johnny. Thank you. Run fast.
There we go. So there we go. There's a nice piece of salt. You can see just how clear it can sometimes be. There we go. You can almost see my hand through it. You can see the red of my helmet almost. And this salt is what this layer of rock is made up of. And salt is a really interesting rock because it forms sort of cubic crystals. So it has a tendency to form as like cubes or cuboids. And you can almost sort of see that in this piece as well. You can see these like lines down the edge that almost have these harsh angles to them, almost like it's got these cubic columns. And because of that, it's quite a good rock for having roadways in. So tunnels like this, roadways like this, are decently structurally sound at this sort of size because of the salt rock's ability to form those crystals. Now, the other rocks that you get underground, potash and polyhalite, form in different ways, so won't have the same properties like that. But the mine also do extra work to make sure that the tunnels stay stable and stay secure. So you can see in the wall behind me, there are every now and again, there are these bolts in the wall. So the tip of my finger's just on one there. And these are like big, big bolts, big metal rods that are drilled into the wall, and they hold the wall nice and secure to stop it from moving and to stop it from shifting. And then where Chris and Beth are as well, behind the walls of the lab, there are these big steel like columns that surround the lab, like a big steel rib cage that adds another layer of protection.
Amazing. Thank you so much, Johnny. So, our next question is about the temperature and the air. So, how hot is it when you are underground, and how do you get the air down there?
So where Chris and Beth are, it's quite pleasant. Inside the lab, it's air conditioned to be about 21 degrees Celsius, so about room temperature. Whereas where I currently am, out in the mine tunnels, it's about 30 degrees Celsius. Sometimes it can be a bit warmer, sometimes it can be closer to 35. So it's like a really, really hot summer's day. And we get the air down. The mine essentially use big fans that push lots and lots of air down the same lift shaft that we rode down in.
Fantastic. And I think we've got time for just a couple more questions. So, somebody wants to know, can people visit the mine? Are people allowed to come and visit the mine? Can our classes come to see the mine?
Unfortunately, since it's in a mine, you need to be 18 to come underground. That's just one of the laws, so that you can be kept safe. But maybe one day in the future, if you'd like to become a scientist, you could maybe work here one day.
Amazing. And what is your favorite thing about your job? I know we asked your favorite part of being in the mine, but you don't just work in the mine. Is there anything that you really love to do, or your favorite experiment that's been underground?
That's a very... Chris, do you want to go first?
Yes, please, if I may. So I absolutely love science. I've always loved science. As a child, I was fascinated by it. And I love talking about science. I love talking to you guys about science today. I love talking to scientists about what they do. I like learning about science. It's a fascinating topic. And so my favorite part of this job is that I just get to spend my days talking about science, learning about science, and telling other people about how great I think science is. That's my favorite bit.
I think my favorite bit would have to be that, similarly to Chris, I do a lot of communicating science as a part of my job. So I get to go to schools, I get to do live links like this, and I also really like telling people about the science that we have underground. It brings me such joy.
And for me, similarly to Chris and Johnny, I just love science, and I've always wanted to be doing some research, and knowing that I work with a team that all have that shared passion, and we're also hardworking as well, because we all love our jobs so much. It's just like a really nice place to be. I never wake up and dread going to work, and I'm always excited for what we're doing that day.
Amazing. So I know that we have got a few more questions that we haven't had time to answer, but we are coming to the end of our poetry workshop today. But it has been amazing. And so one of our questions says, how long are you underground for? I know that you've got a long day, so you're not getting the lift back up until you'll be back on the surface about 5:30. Is that true? Yeah, so you've got a few more hours underground. So maybe you could write us a couple of answers to the questions that we haven't had chance to have a look at yet. But thank you so, so much. And I will just share the links in the chat to the Boulby YouTube channel. So we have loads of videos on there that you can have a look at, that you can have a watch of, if there is anything that you want to learn a little bit more about, you can maybe find out on there. And that is one of the places that we will share the videos of the people that have entered, when you've entered the competition, the ones that we will share. I've also posted the link to where you can submit your entries. And I believe that Chris has got one final poem for us to finish the session today.
I do. It seemed only fitting that we ended on a poem. So it's a bit rushed, but try this one on for size. That's it from us. the end of our science verse. Over to you to write poems now. Ready for March 21st.
Perfect. Thank you very much, Chris. Very, very lovely. So, goodbye from me and goodbye from my cat. Sorry for the interruption, but a massive thank you to our team at Boulby, and we look forward to reading your poems. We'll send you an email with all the things, so don't feel like you have to catch up on everything now. But we can't wait to read your poems. It's going to be amazing. Thank you so, so much for joining us, and we hope you have a lovely rest of your day. Goodbye, everybody.
Bye.
Bye-bye.
Bye.